Hello. So in this video we're going to go over differentiation rules. The first two simple rules are the constant multiple rule and the sum and difference rule. In the previous video we did the exponential rule. So now we're going to start deriving, not by definition, but just using the rules. So here you have the two rules. They look kind of big, but it's very simple. Look, the first rule, the constant multiple rule, tells you that any constant comes out to the front of the derivative. And the sum and difference rule just is telling you that the derivative splits over a... This will allow us to derive any polynomial when we mix the exponential rule, the constant multiple rule, and the sum and difference rule. We'll be able to do that. But let's go step by step. So let's see some simple examples. We already did the derivative of a power function. I bet you know how to derive this. So yeah, the 4 goes to the front, that's 4x, and subtract 1 from the power, you get cubed, that's it. Alright, now suppose you have a constant in the front. Instead of that you have 3x to the 4th power, and then what happens is the 3 goes to the front. So this is 3 times the derivative of x to the 4th power. So this is 3 times the derivative of x to the 4, as we did before, is 4x cubed. So this is 12x cubed. You can do this shortly, knowing what's happening inside, just by saying this 4 is going to multiply the 3, and that goes to the front, and then I subtract 1 from the exponent, and I get my derivative. You see? Easy. Let's derive a couple of simple ones. For example, dx of, let's say, 6x to the 5th power. The 5 multiplies the 6 in the front, so that's 30, and lower the power by 1. Also, if we have the variable in the denominator, something like 3 over x squared, well, you rewrite it with a negative power and use the power rule. So that's the derivative of 3x to the negative 2nd power. And now the negative 2 multiplies the 3. So in the front, I'm going to get negative 6 and then lower the power by 1. So that's negative 3. So my answer is negative 6 over x cubed. Easy. Now let's look at examples where we use the sum and difference rule. Let's do something like dx of 2x cubed minus 3x plus 1. I'm going to do this only once the long way so you see why things happen, but then you're going to do it faster. So using the sum and difference rule, this splits. So this is the derivative of the first term. The minus comes out, minus the derivative of the second term. The 2 comes out, and you get the derivative of x cubed, minus the 3 comes out, and you have to derive just x. And well, we know that the derivative of a constant is just 0. And then this is going to be 2 times the derivative of x cubed, we already know, is 3x squared, minus 3, the derivative of x is 1, and that's it. So this is 6x squared minus 3. Let's practice this with one more example. Let's do the derivative with respect to x of 6x to the 4th power minus 3x squared plus 2x. Now we do it faster. We know it splits, so we can take the derivative of this term, then this, keeping the signs. So the 4 multiplies to the front, and you get 6 times 4, which is 24x, and lower the power by 1, 24x cubed. Keep your sign, and then multiply the 2 to the front to make 6x, and 1 power less is just x. And then the derivative of 2x we know is 2. Easy. You see how we're ready now to derive polynomials? It's not difficult. So let's derive this polynomial. The derivative of f of x is 5 multiplies to the 4, 20x to the 4th power, plus 2 multiplies the 2, 4x lowered by 1. Then the derivative of 2x is 2, and the derivative of 1 is 0. I don't even write anything. Yep, easy, fast. This is kind of a tricky one, but very simple. The derivative of g is going to be the 3/2 multiplies to the front, so you get 3 times 3/2. And then you lower the power by 1. Then the next one, think, what is this? Is that a function? Is that a constant? Is that a number? Is that what? You guessed right, that's a number. Pi is a number. Pi to the 3/2 is a number. And the derivative of a number is 0. So this is just 0. It looks tricky, but it's simple. Pi to the 3/2 is just a number. So we just finished this by putting this prettier. So this is 9/2 x, and 3/2 minus 1 is 1/2. Usually when you're given the problem with rational exponents, you leave your answer in rational exponents. If they would have written 3 square root of x cubed, you turn it to rational exponents, you derived it. Then your answer should look like 9 over 2 square root of x. So the way they write the problem, that's the way you're going to answer the problem. So if the first derivative of a function is a function, then I can derive the first derivative, and that is the second derivative. And I can do it again, and I can do it again. So let's find the second derivative of this function. The first derivative is going to be 6 times 2, 12x minus 10. And then this is going to multiply the sign, so this is negative 5 times negative 2, and then lower the power by 1. So the first derivative is 12x minus 10 plus 10x to the negative 3. Now let's do the second derivative. You just have to derive again. The derivative of 12x is 12. Derivative of 10 is 0. I don't even write it. And then I derive the last one, which I'm going to multiply the negative 3 to the front and lower the power by 1. So the second derivative is 12 minus 30x to the negative 4. Voila! And in this last example, we're going to find all derivatives of this. Polynomials have a finite number of derivatives. It depends on the degree, because each derivative you take, you're lowering the degree by 1 until you get degree 0. That's a constant, and then the last derivative is going to be 0. So let's do the first derivative of g. I'm going to do it in one step. You're ready for that? So this is 5 times 4, 20x cubed plus 6x minus 2. The second derivative is going to be 20 times 3, so 60x squared plus 6. You see how it's lowering? The third derivative is going to be 120x. The fourth derivative is going to be 120. And the fifth derivative is going to be 0. So we found all derivatives of g. Thank you.